Today we're going to be talking about homeostasis, which is a very important subject when it comes to the ability of humans to maintain an internal environment that is stable and allows us to stay alive. So, what we're going to be talking about is basically the idea of negative and positive feedback mechanisms in the human body. Now, when we are looking at homeostasis, we are looking at a couple of things going on. There has to always be something that is going to be changing. And that change can be anything. It can be temperature change, it could be calcium level changes, it could be literally anything that's changing inside or outside of the body. So what we always have to remember when we're looking at homeostasis is we need to look at the actual change, which is the stimulus. There's going to be some sort of stimulus that is going to change. Then there's a receptor. The receptor can be on the skin, the receptor can be in an organ, but that is going to be accepting the stimulus. It doesn't know what is actually happening at that point. The receptor is just receiving the stimulus. The receptor then takes the information to the control center, which is going to be your central nervous system, your brain, or your spinal cord. Within your brain and your spinal cord, you have a set point, which is going to be the set point for temperature, calcium levels, glucose levels, whatever that set point is. So once it gets the information from the receptor, then it will say, okay, there's been a change. What are we going to do about it? We need to make sure that we can make this right and bring it back to the set point if it's not within the parameters that it is supposed to be in. Then it's going to send the information to an effector. Effectors are always muscles or glands. And it's going to send the information to the effector so that it can respond to that stimuli and make things right. So this is just going to be a series of pictures that are going to show you how this works in the human body. So there's some sort of stimulus. The stimulus is going to go into the receptor. The receptor is going to take it to the control center, say, what are we doing? The control center is then going to send the message to the effector, which is again a muscle or a gland, and we are going to try to get the body back into the norm, within that norm, whatever that set point is. Now, in this example, we are increasing something. So this could be an increase in temperature, an increase in glucose levels, an increase in calcium levels, whatever that may be. We can also end up going down or reducing whatever that set point is. So decreasing glucose levels, temperature, etc. What our body mostly relies on to maintain homeostasis is something called negative feedback. And negative feedback, kids always want to think that negative means bad. In this case, negative just means that we are going to change whatever level in our body in the opposite direction of what is happening. So, for example, if I am increasing my body temperature because I'm out in the sun or I'm working out or whatever that may be, my body is going to try to decrease the temperature to maintain homeostasis. So this picture is just showing you an example of negative feedback, of a negative feedback loop, but in a house. So when we are in a home and our temperature goes up, we have a set point. We have put the thermostat on a certain temperature, and as the temperature in the room increases, it's going to send the message to the control center, which is then going to turn the air conditioning on or turn the heater off depending on what is going on. And then obviously the opposite is true when there is a decrease in that same room temperature. Now, positive feedback is the exact opposite of negative feedback. We don't have any true positive feedback mechanisms in our body, but we do have some temporary positive feedback loops. And what a positive feedback loop does, instead of trying to turn off or change whatever is happening, it is going to continue to exaggerate that change. So one of the best examples in the human body is blood clotting. When when we're going through the process of clotting our blood because we've broken a blood vessel, our body is going to continue to increase those clotting proteins and that clotting mechanism so that we can stop from bleeding out. Another example of a positive feedback loop is labor contractions in a woman during um, or when they're ready to give birth. Those, the contractions start out and they're maybe spaced far apart, and as it gets closer to actually giving birth, those contractions get stronger and start happening sooner and sooner over time. Now, again, in a human body, positive feedback is it is always just for a brief period of time, the positive feedback mechanism, and then it will go back into the normal negative feedback mechanism. Now, if there is some sort of homeostatic imbalance, meaning that your body cannot control um, whatever that change is and cannot reverse what is happening in the body, sometimes your body will go into a destructive positive feedback mechanism loop. Like, for instance, if your body temperature increases and you are now starting to overheat and your body cannot control it any longer, it will go into a positive feedback mechanism where it will just continue to heat up the body and not cool it down. This is when there's going to be a problem. This can lead to death, and I'll give you guys some examples of this when you come back to class.